Our goal is to fundamentally change digital manufacturing by using unique hardware and novel algorithms that we have developed as part of our Smart Pebbles system. In particular, we want to create objects using a distributed duplication process. We envision burying a passive object in a collection of millions of smart particles that can communicate and bond with their neighbors. The particles bordering on the passive object sense its shape and then instruct spare particles nearby to selectively bond with their neighbors and create a duplicate object. Here we use a simulation to demonstrate our system. We start by surrounding the original shape, in this case a wrench, with robot pebbles whose mechanical bonds flash orange as they communicate. The basic idea is to identify and duplicate the particles on the border of the original shape. These particles turn blue and then yellow when they realize that they are part of this border. As the particles turn yellow, each sends a message to its conjugate border particle, shown in purple, that lies some automatically calculated distance to the right. Once the conjugate border is complete, the system performs a flood fill process to notify all particles inside this new duplicate border that they are part of the duplicate shape. As a result, they turn orange. When the system determines that all particles that constitute the duplicate shape have been notified, it initiates a self-disassembly process. This results in all modules except those that form the duplicate shape breaking their mechanical bonds with their neighbors, leaving only the original and the duplicate behind. We designed and built 50 robot pebbles. Each is a 12mm cube with 4 electrically switchable magnetic connectors that is formed by wrapping a flexible printed circuit around a brass frame. Here we use the pebbles to duplicate a simple 2-unit rectangle. The pebbles are on an inclined vibration table that is controlled by the variac on the right. As we change the amplitude of the vibrations, the pebbles migrate to the lowest point of the table. They align and self-assemble into a rigid block around the shape being duplicated. We are helping the pebbles form a perfect rectangle because the system will use a placement algorithm to automatically determine where within the original block of material to place the duplicate shape. This algorithm works best when the initial configuration of particles is rectangular. Now that the pebbles are assembled, they begin to communicate. As shown in the simulation, they sense the shape of the object being duplicated and then automatically determine which pebbles should become the duplicate object. Once the pebbles that form the duplicate have been notified, the self-disassembly process starts and the pebbles begin to break their bonds with their neighbors. When complete, all of the mechanical bonds except the bonds in the duplicate shape are broken. The user can then brush aside the spare modules and remove the duplicate and the original shapes.